All right, so here's example 4. And again, write this down first, and then we'll explain it and talk about it. All right, so we're supposed to write the rectangular equation x minus 3 quantity squared plus y squared equals 9 in polar form. So we have x and y's here, and we need to change that so we have r's and thetas. We can have cosines in there, we could have sines in there, but it's going to be r's and thetas that are going to be inside this problem instead of x and y's. So again, looking at this, I'm going to rewrite this equation down here. And again, because we're dealing with x and y's, that's our rectangular. And we need to get to polar, so we're dealing with sines and cosines, thetas and r's. So we already know x equals r cosine theta. We know y equals r sine theta. And then from there, we might have to pull in some Pythagorean identities. So again, like I told you guys before, we're not done with those. Our trig stuff is not done. Our trig identities and our trig values and all that good stuff that we learned already is not over with. So that's what we're doing now. So here, we're going to use our x and our y's here to change them over so that we have r's and thetas. So here for the first portion of it, we're going to change that x over to what x equals, which is r cosine theta. And we'll keep everything else the same. And then for y, our y is r sine theta. Nope, sorry, not y, just r sine theta. Quantity squared. And if you're thinking about a trig identity, you should hopefully remember something that's come into play when it comes to your squares and you have sines and cosines. Something should be like popping into your head really quick because we've hit that one a bunch of times in the trig identities. All right, now, with this next part, because you know that you have a square there, you know that doesn't go this here into here, that means you have two of these, which means, and I'm doing this extra step, which I didn't do this extra step last year, but I'm doing it right now real quick. So it means that you're going to have to be able to do box method or FOIL, whichever one you learned. And I'm going to fly through that part because you guys already know how to FOIL, how to do box method. So that shouldn't be something that we have to focus on and deal with. And so here, r times r is r squared. Cosine times cosine is cosine squared, theta. Then we have r cosine times -3, which is -3r cosine theta. -3 times r cosine theta, so -3r cosine theta. Then -3 times -3 is +9. Then here we're squaring it, which means you have 2 r sine thetas. So that means we're going to have r squared sine squared equals 9. And if you need that part worked out, ask me in class, and I'll really quickly over there show it to you really quick. But again, that's something that you'll be able to get quick. You should know already how to do. Okay, now for this first portion here that we did with the cosines, those are like terms, so we can combine those. So that's r squared cosine squared theta minus 6, 3 minus 3, -3, and a -3 is positive, -6, sorry. -3, -3 is a -6, r cosine plus 9. And think of that r cosine as x, so -3x and -3x is -6x. And x just means r cosine theta. So that's what I was about there again. So it's just like a regular function that you've dealt with before, when you had to factor and simplify. Okay. Now the other part that we can do is start simplifying things and trying to see if we can get things to cancel out. So here we have a +9 here and a +9 here. Let's just try to get that on the same side so we can get it to simplify. Because our goal is to try to get r equals, Because remember, when it comes to our polar equations, we'll write this down at the bottom, so give yourself a lot of space there. But for our polar equation, that means we're looking for r equals something. So that means on this side, we need to keep our r's here. And then on the other side, we need to have like cosine or a number. So here, we need to get that 9 over here so we can kind of get r by itself on this left side. So we're going to subtract 9 from both sides. That cancels. And this actually ends up canceling. So we get 0 on the right side, which is okay. That's perfectly fine. So don't get scared about that part. Well, Mr. Hall, you said... I didn't really say anything about that, so it's okay. It's okay. It is okay. All right, now, something should be coming back to you when it comes to our trig identities with a sine squared and a cosine squared. And it was something that broke it down, made it one simple number and all that great stuff. So what I'm going to do is I'm going to put those two together next to each other. And because this is all, these are all on the same line, we're not going to change the signs. We're just going to move things around. So I'm not going to change any of these signs. I'm just moving things around so that we deal with our squares together, because it should, again, bring back memories of something that we've dealt with when it came to our trig identities. So here, this is a cosine squared and sine squared, but the only difference between it is that there's an r squared here right now here. So before we do that, let's go ahead and move this over so we can deal with just this part right there. And if we need to move that back over later on, we can. So I'm going to add 6 to both 6 r cosine theta to both sides. So I'm not going to write that step down. I'm going to skip it, but I'm telling you we're going to add the 6 r cosine theta to this side. So that way we can just deal with this side right now. And if we need to move it back over, we will. But if we can keep it there and be done with it, cool. Okay, so I knew I should have wrote this like lower. So here I'm going to actually move this down lower here, or I'm actually going to do something different. All right, so here, before we do that part, I'm going to go ahead and factor out what they have in common. So the only difference between this and what we talked about before with our Pythagorean identities was that it was cosine squared and sine squared, but no r squareds. So if we factor out that r squared, it gives us back the cosine squared plus sine squared. That equals 6r cosine theta. And again here, I'm going to mark this out because I thought I had enough space up there, and I didn't. But again, our goal at the very end of this is so that we can get r equals something. So that's what we're going to end up getting to. R equals something. We don't know what yet exactly, but we'll get there. All right, so looking at this part, this brings back a trig identity, which hopefully you guys remember it. I'm going to just write this down here. So leave yourself, like, you can throw it in the middle here of the problem, but put it off to the side so we remember it. So we have sine squared plus cosine squared equals 1. This is commutative because it's an addition sign, it's not subtraction, so it doesn't change the value of the sines or the cosine if you switch them around. So sine squared, cosine squared are commutative. We can move them around. So here, that means the cosine squared plus sine squared equals 1. So here, we're going to do r squared. And inside our parentheses, we're going to put the number 1, because that's what sine squared and cosine squared equal. And then we're going to equal 6r cosine theta. So again, all we did was take this portion here, what's inside the parenthesis, looked at it and it's like, okay, that's this right here. But to simplify it down, that means that this equals 1. So let's just change this over to 1. Which makes life so much easier. So much easier. All right. So then we have r squared equals, because 1 times r squared is just r squared. And we get this part here. And again, our goal is to get r equals something. So here, if we divide both sides by r, can't we get that down to just r itself and not r squared? And we have an extra r over here. Okay, so that means the r's cancel out. 1r cancels out with that squared, so we're left with just r equals 6 cosine theta. Oh my gosh! Look at that. Now I know that one's a lot more work than the first example 3, but this one is going to take time where you have to think about the identities and all the great stuff. So you're going to have a plan, a game plan here of trying to figure out what can I do to get things to cancel out and try things out. You'll have practice with this. It's not going to be one of those things that I just give it to you now and just be like, go, go, go. You have a test on this later on also, but with it, we're going to work some more problems with this and make sure you understand before you actually just go right into a test. Right? But that is the end of it. That's all there is of changing from polar to rectangular to polar. And it's important that you know how to do both, all 4 of these examples, because you might see them on a final exam. You might see these types right here. So don't just throw it away. Keep it in your head. All right. So that's it.